Hello, and welcome to reInvent. Thank you for coming to this session here. This room is packed full of people, and thanks for coming here, for choosing this session here. My name is Constantine Gonzalez. I'm a I'm a principal solutions architect, technical person in our company. And this is Jason Fuller. He is head of cloud management and operations. And together we're going to walk you through running lean architectures, how to be cost effective on AWS. So if you happen to lose some money at the tables yesterday, this is the session to recoup it. And actually, I'm giving this session like the 7th year in a row, and it's always a very fully packed session. Every year I try to bring in something new, so that even if you were here last year, you should pick up something new here. And every year my goal is to save you so much money that you can easily pay for next year's reInvent, including hotel and travel and everything. And you will figure out how to do that. So let's get started. So what are you going to get out of this specifically? First, we're going to talk about best practices on how to lower your AWS bill, because this is what you're here for. But you will also learn how the same best practices can help you build a more scalable, more robust, and more dynamic architecture. So it's not a trade-off. It's actually a win-win. By saving money on AWS, you will automatically be more efficient and get other benefits out of that. You also learn how to save time to innovate, because time is more valuable than money. You can always make more money, but you cannot make more time if it's gone, right? So learn how to save time and be more innovative here. And then we're going to see some real-world customer examples. This is all about practice here. We're going to talk about the theory, but all of that theory has been put into practice, and it is proven to work. And then all of these things are easy to implement. So when you walk out of this session, think about how you can put these things into practice today or tomorrow or next week so that you are on track to paying for your next year's reInvent. Now, even if you don't do anything, and I know I'm a lazy person myself, we're working hard to save you money, because the AWS business model is really based on reducing prices, because when we reduce prices, we see more customers, we see more AWS usage, we get to build more infrastructure, which give us better economies of scale, which allows us to lower our infrastructure costs, and that in turn is something we'll give you back to you as customers, so you can save more money by reducing our prices yet again. And there are two accelerators in this model. First, we also invest a whole lot of money into infrastructure innovation. And you've seen during Andy's keynote how we introduced the Graviton 2 servers with a lower price per transaction. We introduced special chips for machine learning. And the goal is not to be faster, the goal is also to be more efficient and more money saving with our infrastructure innovation. So that also helps us lower infrastructure costs. Now, the other accelerator is the more usage we see, the bigger the community is, more partners. And you see the partners in the Partner Expo here. More people using our features, people giving us feedback so we can build new features and new services, and that makes AWS more attractive. Over time, since 2006, we were able to reduce prices 77 times already, and we're nowhere near done reducing prices here. Now, this room here is full of builders. You're all builders, and that's great, because as builders, you're taking your own destiny into your own hands. You build it, you run it, and you optimize it. Now, what's the difference here between being a builder on AWS and the classical IT? Well, in the cloud, your biggest strength as an architect and as a builder is architectural flexibility. It means you're not building anything in stone in the cloud. It's always flexible. You can always change your architecture in the cloud. You can always optimize it, and you're never really done, which gives you this agility that people expect from the cloud. So when you build something in the cloud, your main goal here is to avoid unnecessary stuff, right? You try to take waste out of your system. It's okay to start with a minimum viable architecture and see if it works, and then you can start iterating and try to get rid of things like unnecessary resources, idling resources, or stuff that is repetitive that you could do more efficiently here. So as you go about this process of re-architecting and improving your architecture on AWS, there's a small process that will help you along the way. And you can think of it as your own small cost optimization flywheel, if you will. And it always starts with measuring your current cost on AWS. And after getting insight, getting transparency about your cost, you can then start coming up with ideas on how to build a better architecture. And once you have those ideas on paper or in your favorite IDE, then you start building them into your architecture for real in the cloud. And the first step is always to measure your existing costs so that you know where you're standing, and then you can plot a course to where you want to be. And the best way to start with that is by using the AWS Billing and Cost Management dashboard. You should be very familiar with this dashboard. If you haven't seen this dashboard before, go do this as soon as you leave the session. And because here, you get a real complete picture of all of your costs broken down in any foreseeable dimension, including a budgeting function. You can set up a budget here, and you can set up a budget for the next weeks, months, and, well, probably not years, but for the next couple of months, and get a better planning ground here. And the budgeting function will give you automated notifications. It will send you emails when you're reaching certain milestones in your budgets so that you have full cost transparency and you always know what's going on. And the console also comes with a cost explorer. You can drill down your bill with the cost explorer, identify the big chunks so that you know where to start with saving money. It also comes with an API that you can integrate with your monitoring systems so that you get a near real-time feed of your cost on AWS. Now, the most popular way to save money on AWS is to use EC2 reserved instances. And reserved instances really mean that you commit to a certain usage of EC2 and you get a discounted hourly rate in exchange. It's the classic discounting scheme that we've been seeing from so many retail businesses over so many centuries ago. In the very beginning, reserved instances were also tied to a certain capacity that was guaranteed. If you bought 4 reserved instances, you got the capacity reservation for 4 reserved instances. Today, these two things are decoupled. So capacity reservations are optional now, so that you have the freedom of whether you just want to save money or whether you also want to have the guaranteed capacity with it. Reserved instances are available in 1-year and 3-year terms, and you can save up to 75% compared to on-demand in exchange for a little bit of planning. So the only downside is you commit to a certain amount for a certain period of time, like 1 or 3 years, and you need to be a little bit more planning. So if you see something that you're pretty sure you're going to use over the next year or so, then reserved instances is probably a good choice here. There are 3 types of reserved instances. There are standard, convertible, and scheduled RIs. And if you are unsure about which one is right for you, go to the AWS Cost Explorer, because the Cost Explorer will give you personalized recommendations based on your historical usage. This is how it looks like, and it will tell you, okay, if you do this, you will save so much, and if you do this other version here, you can save so much. So use those recommendations and try to understand better how those reserved instances can help you. Now, going back to our flywheel here, the next step here is architect. So let's get more technical here, right? So in architecture, the easiest way to save money is simply to turn off unused instances. This sounds super obvious, but if you're coming from an IT background and if you're coming from an on-premises world, this is something you have to learn, right? I mean, in the on-premises world, you bought hardware and you put hardware, and I cut my fingers and you bleed, and oh my God, the hardware. And then it was sitting there for 3 to 5 years, and it was running 24/7 and consuming all that power and cooling stuff. In the cloud, it's not necessary. So where are those unused instances? So think about developer instances, test instances, training instances. All these instances don't have to run 24/7. You can switch them off during the off hours of the day, over the weekend, and then they will stop spending money for you. You can start and stop those instances. You will not lose the instance data, because you're putting that data on EBS volume and they continue running, but you will stop paying if you stop those instances. Thing is, you can apply this concept to whole architectural setups. Even if you have a complicated architecture with web servers and app servers and farms and everything scale out and wonderfully complex, you can shut down everything through automation by using things like CloudFormation or Terraform here. So think of instances in the cloud as something that is disposable, that you only use when you have to. And this is how much you can save. So this customer here, this is their usage of EC2 instances. On the y-axis, you see how many instances they're running. On the x-axis, there's time. And you can see how the weekend and the end of the vacation season is visible in this graph here. And in this particular case, this customer is saving 35% just by being smart about stopping instances that they don't need anymore. Now, I briefly touched on automation, and my recommendation here is to automate everything. You should be running 100% fully automated in the cloud. And you can do this with so many things. You can do this with the command line. You can use more sophisticated approaches. Doesn't matter what tool you use. The important thing here is to automate. And the easiest way to get started with automation is to use EC2 autoscaling. Because autoscaling is a mechanism that will adjust the amount of instances that you need in the cloud. It will adjust them automatically based on demand by using our monitoring system CloudWatch to measure how much demand there is in the form of latency at the load balancer, for instance. And it will automatically start new instances and terminate unused instances to be efficient and to follow the curve of demand automatically here. You get 3 wins here. First, you get automatic capacity management. Always the right capacity, no matter whether you're having large demand or low demand. Second win is automatic mitigation against failures. If an instance goes bad, because after all they are running on hardware, if it goes bad, it will automatically be replaced by a new instance. No need to do anything here. It will automatically heal itself. And you get automatic cost optimization here. So to summarize this first bit here, the old thinking in the on-premises world was of thinking of servers like pets. We all love pets, right? I have 4 mice at home for the kids here, and we love them, right? But the cloud is not the place to think of servers as pets, because think of servers as pets is individual servers. And remember, back then, I used to give my servers names. And they were manually administered. But manual administration creates the potential for configuration drift. And then you're running with a configuration that is not documented very clearly, which creates the potential for error. And that creates a lot of work, especially when things go wrong. And it shouldn't be that way. In the cloud, think of your cloud instances, of your cloud resources as cattle that are very highly standardized. All of the servers are the same because they're automated, right? Highly automated, less error potential, and less work to do. And that means in the cloud you can build a more efficient architecture because you're thinking of servers as cattle now, and that will give you lower cost. Now, another way to save money is to use EC2 spot instances. Who's using spot instances now? So a couple people do. If you didn't raise your arm, find people who did raise your arm and ask them about spot instances. So spot instances essentially give you access to spare capacity on AWS, which is priced based on supply and demand. And you can save up to 90% money by using spot instances. So you will probably ask, so what's the downside here? Well, there's a small downside. If we need those instances back, because we found a paying customer for our spare capacity here, then we will terminate those instances. But you get a 2-minute warning, and you can react to that warning automatically through automation, for instance, by using autoscaling, right? So you can use autoscaling to combine spot instances with on-demand instances and reserved instances and get the best of both worlds. Now, spot instances in the very beginning used to be complicated. And this is an old ancient graph of spot instances many years ago, and you can see how chaotic the prices can be. Today, spot instances are really well understood. You get very simple, very smooth graphs of the pricing. They're very predictable. They're always cheaper than on-demand instances, and they're very easy to manage, especially if you use tools like Spotfleet or if you're using autoscaling, because now autoscaling has its own little tick box that you can check off if you want to combine spot instances with on-demand, and then you can save a lot of money here. Okay, that was a bit of theory. Let me bring on Jason to the stage here, and he will tell you how to put this all in practice and what here is doing with all these things here.
Thank you, Konstantin.
Thanks, Jason.
So my name is Jason Fuller. I'm the head of cloud management and operations for a company called Here Technologies. Some of you might not have heard of Here Technologies, so I'll put up my obligatory marketing slide. I'll spend as little minutes as we can on it. Here Technologies is a very large platform company that runs location globally. So our biggest competitor is on the West Coast in the United States. We probably all use them for many, many things. I won't say the name. But ultimately, we're the #1 platform in this space, so we love competing with those guys. But you can see some of these numbers, and they're huge. And the reason we can achieve these numbers is because we use AWS. So when Konstantin called me a couple months back and said, hey, you're a huge user of AWS, you're also very efficient in how you use AWS. We've achieved over 50% run rate reduction through cost avoidance exercises, exactly the way that he's laid out for you today. So what I'm going to do is just take you on a brief journey through how we got there, what challenges we faced, what lessons we learned, and hopefully you take away a little bit from here and maybe pay for reInvent. So your traditional RI strategy, if you're in an enterprise that went cloud a while ago, maybe not yesterday, but a few years back, innovation and speed to innovate was one of those decisions you took on whether there's a bottleneck and you force people through a sourcing process or through a financial process, or you let the builders build. We let the builders build. So when I arrived at Here Technologies in 2016, we have over 500 accounts. We have over 10 million unique instance IDs per year, well over 200,000 concurrent running all the time, and very little RI coverage. Teams are very much allowed to do what they want with their architecture. Good architectural practices within each team, but these are 500 islands that are all interacting with each other, but interacting in an independent way. We had limited reporting at that point. If you remember, we were using AWS's detailed billing report, the DBR file. We convert over to the cost utilization report, the CUR file. If you haven't looked at this billing file, it's a bit like looking at your teenager's cell phone. So prepare yourself. Lots of good data, but very big. Ours is over a terabyte CSV, which means I have to pay AWS to open it because I have to put it into Redshift. So always good. So we said, listen, we need a new proposal here. We need a way, as a company, for us to centralize this process. Teams are not going to make year-long or 3-year-long decisions. They're working in AWS. They're working on highly technical, very, very large-scale big data, deep data problems. They don't want to talk about, am I going to give an RI 1 year or 3 years? And so that's part of the reason when we interviewed a lot of teams why they said we didn't use RIs. We just didn't feel like we could commit. We didn't know. We wanted the freedom to change. So what did we do? Anybody in the finance department of their company in the room? I see a show of hands. Raise your hand. Yes? 1, 2. Perfect. We'll talk later. We went to you first. We said before we go down the road of architectural debate and decisioning and builder versus builder and all these great, very positive, nobody was being angry yet, let's go talk to finance. What is it exactly that you see that's wrong? And of course, finance's answer is always, AWS is too expensive. Okay, let's talk about RIs. We go to build in with our management team and say, okay, at a fleet level, all the islands, we have a huge amount of RI potential. So we show the potential. And then how are you going to achieve the potential? Well, we add technology to the mix. How much are we going to be able to do from a reporting perspective? Who in finance receives reports? Who in management gets the KPIs? Who's held responsible if the team changes architectures? One of the challenges with RIs is that it is restricted to your OS, it is restricted to your region, it is restricted to standard versus dynamic. And so we made some decisions. We said, we think we'll take a look at this and we will say 1 year only, Linux only, in the regions only where we see greater than 5% usage. And we used a vacancy solver, which basically we replaced with a commercial tool later, which said, if no team is using an RI, that's a bad investment. But the RI floats. So if you take an RI and you buy it in US East and you have 50 accounts that are using US East, one EC2 instance goes down in an auto-scaling event, another instance will receive the same benefit. Now, if you're an individual team and you just invested $1 million in RIs, 20% of the time it spends time in Konstantin's account who's invested $0 in RIs, he just got free lunch. So that wasn't a positive thing of the RI program. And what we did was we took the ARNs and we mapped them. We know when we bought them, we know what account we bought them in, and we make sure that only the team that used the RI paid for the RI. So 100% managed ARN coverage of RIs. So figured all this out on paper, start to put it into action. We incorporated a concept of green zone, red zone, and green family, red family. This is your simple, first sigma away from the center type activity. What does our model show us? That if your instance family is greater than 5% utilized in the fleet, and your region is greater than 5% utilized in capacity, then the potential that you drop an instance and somebody else is there to pick it up is high. That confidence gives us a matrix which we can then buy against. We created an implementation where we control locked you. Teams could not buy their own RIs. We did bottleneck at that point because we had such a low team initiation. We said, fine, we'll handle it. You can't buy it anymore because you'll mess up my reports if you do. So we block them. We actually do this through organizations. If you're not the enterprise team that owns organizations, get close with them if you're going to implement this program, because they can write a policy that says, remove RI buying from the console, block the API from the team. And what that does for us is it allows us to say control, buying, sourcing, and finance are happy. Teams are happy because their prices are being reduced, but teams need communication. So developing a good report and a good order, who's in charge in your team, which island owner is going to be contacted, and once a month we say, hey, these are your renewals. If you don't tell us to stop, we're going to renew. We took an opt-out approach, right? So what did this do? It opened up a couple of things. First of all, after the success of this program, and I'll get into the lessons learned and the numbers in a minute, we saw other opportunities. Well, if teams aren't buying RIs, are teams paying attention to Trusted Advisor? Are they looking at instances that are left on all the time? And if you haven't used this API, I would highly recommend it. This is a screen capture from one of my Splunk boards that shows my teams and how much they're wasting in the cost pillar. So Trusted Advisor gives you data on the best practices of the well-architected program that AWS uses as their foundational bedrock for how you should architect AWS. What we do with this data is we then find the people who are going to waste over $10,000 that month, and we come knocking on your door. Excuse me, did you know you're wasting over $10,000 this month? This isn't a good thing for anybody in the company. What can we do to help you with architecturally changing this? So pull the API into a dashboard, make it visible, make it the leading thing you talk about with teams. Let's go to the dashboard. Let's work on it together. There are commercial companies out there that do this, if you're more of a buy than a build, but I hope you're building. And then make sure that you bring in other tools. So one of the things that we started doing was the personal health dashboard. When am I going to see failures because AWS changes something? This is like your large-scale status.aws.amazon.com for you. So my EC2s failed. Why? Because AWS. My RDS failed. Why? Because of AWS. But it's mine. It's in my account. It's an account-specific way to look at change management. So we drive all these things. What happens? Builders build. Everyone gets excited. And we get to a point of this. This is this year's project where we right-size automate based on heuristics of your EC2. So teams don't look at us as the bad guys anymore, 3 years fast forward to today. We've saved you a lot of money. We've shown you where you might have holes. We've taken those worries off your back because you can build, and confidently there's a central team there that catches some things as a safety net. So the team built this year. It was a really fun project using Lambda, Aurora serverless. Effectively, what we do here is we pull a heuristics report of your EC2 usage. We look at your CPU, your memory, your I/O, your bandwidth. We compare it statistically against your usage when you're using it. So what you'll find in the market is a lot of teams and a lot of companies will look at a 24-hour clock. We all go to bed. Instances sit idle. Zeros screw up averages. So we only look at it when you're using it. And from there, we recommend a different EC2 instance. This family would be better. This size would be better. The teams now have an architectural guide that helps them. And to push them along, we drop them a ticket in their Jira queue, which engineers love when you put Jira tickets in their queue. And then we take action on it 2 weeks later if you don't. So if you ignore me and you don't talk to me through the Jira queue, I go out and stop your instance. But I don't do it in 30 seconds, which is best practice. I do it in 2 weeks. So we give a lot of time at Here Technologies. Some companies you'll talk to will say, yeah, give them 3 seconds. because builders won't do anything. They won't put anything on an instance 3 seconds later. If it's not tagged, kill it, right? We can get into that offline. So the results. Greater than 80% coverage in year one. We've held over 85% for 3 years. This means that my EC2, which is 65% of my spend every month, is 85% covered with RIs, which is gaining us about 50% off of the on-demand rate, okay? Teams became cost aware, right? As I showed you, we expanded this situation. So we said, oh, RDS, done. Elasticache, done. We kept moving. Dynamo, done. So every time that an RI program at AWS is released, we have the wash, rinse, repeat program in place to build the next RI program for us. And in 3.5 years, this has given us $50 million back in the bank, and it's avoided $150 million of spend that we didn't have to worry about trying to save. So from here, we keep enhancing, we keep automating, right? AWS keeps announcing things. It's a great, it's a great flywheel program. They announce, I have to go react. We keep enhancing our finance folks. So the two of you and I will talk after. And ultimately, we build in custom metrics. So what should you watch out for? We instituted this in 2016 in Q4, which means that every fourth quarter for the last 3 years, I've had a huge RI bill that I want to pay because the renewals come due once a year. So we've tried to spread this out, but I would recommend spreading it month by month or week by week, but move it into the year so that your finance people don't look at the fourth quarter like they do with me and say, do we really need to put these millions of dollars to work? Don't let people tell you they need an exception. Oh, I have an X32 in Sydney. It's not part of the green program. We would really love an RI. No. Nobody else is using it. Nobody else is in Sydney. Please don't come to me. You know, we'll help you with buying an RI because I blocked you, but I'm not going to put it into my program that then measures and monitors and my KPIs, right? So protect yourselves. And make sure you look at some program designs. So blending price, if you're not using blending, use blending. We give the teams the savings so they see it in their invoice. Other companies I've advised for and talked to, they hold that savings in a bank account. They distribute it as necessary. So there's some tricks there with how the money actually gets just, sent out. And then for us, FinOps is the goal. So the goal is that finance can run these programs, and finance can be a partner to the engineering team so that my team doesn't have to consistently sit between finance and operations. So I didn't mention savings plans because you're going to get into it, but we are using savings plans extensively, so it's a really great program too.
Thank you, Jason.
Thank you.
Thank you. Did you hear that? 150 million costs avoided, another 50 million costs saved. He could have paid for half of all the attendees to go to reInvent. So I challenge you, Jason, next year I want to see you paying for all of the attendees. So Jason mentioned savings plans. So AWS savings plans is a very new way to save money. And so what are savings plans? Savings plans are a new flexible pricing model that you can take advantage of that can help you save up to 72% on your Amazon EC2 usage, including AWS Fargate. So you heard about AWS Fargate. This is our serverless container service where you can simply start containers and then forget about them. We just introduced Fargate for EKS as well, for Kubernetes as well. And now you can save up to 72% very, very easily because the only thing you need to do is you commit to a consistent usage in terms of dollars per hour without specifying a specific instance type or any other complicated thing there. You simply say, okay, I think I'm going to spend that much money per hour on AWS. Figure it out how to save money here. And you do this over 1 or 3 years. And in exchange, you get a discounted price list. So you receive a lower price for everything you use in terms of EC2 and Fargate with savings plans. Very easy to use, very good savings, and very flexible. So flexibility is the key behind savings plans. There are 2 types of savings plans. The first one is called compute savings plans. It's the more generic one. And compute savings plans are flexible across the instance family, across the region and the availability zone, even the region. So you don't have to say, I'm going to save money in the Frankfurt region. I'm from Munich, so that would be my region, or in the whatever other region you might use. You can be totally flexible across regions here. You are flexible across operating system, tenancy, or whether you use Amazon EC2 or whether you use Fargate for containers. The other savings plan type is called EC2 instance savings plan, and it's more tailored towards EC2 instances. And in this case, these savings plans are flexible across instance size, but not family. So you have to commit to a specific family here. Availability zone, operating system, and tenancy. So in a nutshell, the difference is with the compute savings plan, you get the greatest flexibility, and you can save up to 66% off of the regular price. And with the EC2 instance savings plan, you can save up to 72% in exchange for a little less flexibility, but still a lot more flexible than the traditional reserved instances. Again, go to the AWS console. It will automatically give you recommendations on which savings plan is the right plan for you, and you can figure out, do some simulations, and see how this will play out in the future for your own bill. Now let's move on to more sophisticated ways of saving money, because there are still so much stuff you can do to save money. Let's start with serverless computing. So who's using Lambda here, AWS Lambda? Okay, quite a few people here. So serverless computing in a nutshell really means that you never pay for idle time, because if your Lambda function is not running, if nobody triggers your Lambda function, you don't pay for anything. So that's great. You only pay for the execution time of that Lambda function, but that means you have to avoid wait cycles within the Lambda function too to be really efficient here. So what do I mean by this? So let's take a look at this Lambda function over here. In the beginning of the function, this Lambda function does some API call, which is an HTTP RESTful request. And then you need to wait for that call to happen, because stuff travels across the internet, and then you get a result. And in between, you have I/O wait time. And then you do your second call and your third call, and maybe you're gathering some data from 3 different sources. So the overall execution time of Lambda is going to be dominated by waiting for those calls to happen. And that wait time is time that you have to pay for. So the remedy here is to use non-blocking code instead. Try to be smart about how you write that code, and try to group all of those initiating requests in the very beginning. For instance, by using multi-threading. You can do all of these requests very, very quickly by putting them into separate threads, and each thread waits in parallel so that the wait time, the execution time, shrinks down to all of these threads waiting in parallel. And then you collect all of the results and get done, and that will lower the overall total execution time. Strategies on how to do this is you can use event-driven code, for instance with Node.js, or you can use multi-threading with Java or Python. And here is an example of a Lambda function that I'm using for my own personal setup. This is a Lambda function that aggregates RSS feeds across multiple sources. And in the beginning, of course, I did the lazy thing. I did the simple way that does this one after the other. And over time, this Lambda function was growing in terms of total execution time. Then I implemented the multi-threading code, and boom, 60% less Lambda usage time, 60% less Lambda cost. The other thing you can do is sometimes we have to wait inside our code. So for instance, you might start something like a complicated database request, and you want to wait until that request has been completed, or you're starting a batch job or something else. And then you have this loop kind of thing where you say, OK, is this thing done? No, let's wait for 10 seconds. Are we there yet? And another 10 seconds go by, and you pay for all of these wait cycles. So whenever you see an explicit waiting thing like time.sleep here, be alert, because there's a better alternative. And the alternative here is to use something like AWS step functions. AWS step functions is a very simple workflow execution service, and you can model the waiting and the checking for your results in step functions. And the waiting inside of step functions is for free. So you might say, OK, Konstantin is nitpicking here. This is very, very, very specific. How much money can you save here? So here's an example. Our customer, Coca-Cola, they have a system that updates their loyalty database whenever you buy a bottle from those automated vending machines. And they've been doing the simple thing first. They wrote the Lambda function. The Lambda function was waiting 90 seconds per bottle. And then they refactored their code into using step functions. And now they are saving 90 seconds of Lambda execution for every single bottle they sell through their machines. That can add up to a lot of money here. The other thing you can do in your architecture that is just a little bit sophisticated but pretty easy to set up is caching. So you might know caching about, yeah, this is a way to make stuff run faster, right? Yes. But fundamentally, caching really means that you do the expensive stuff only once, and then you reuse it as many times as possible. And that is a great way to save money, because memory tends to be cheaper and faster than CPU execution cycles. And the great thing about caching is that you can cache everywhere. You can cache at every layer of your application. The only thing you need to keep in mind is you need to keep track of how old is this cacheable item. Is it still current? Which is a little bit of application code that you need to put on top of that. But once you have that, you can cache at the database level, you can cache application server level, you can cache at the web server level, at the edge, you can cache inside your users' browsers, you can cache everywhere. And the simplest way to get started with caching for a web application is to use Amazon CloudFront, which is our content delivery network that includes caching in 210 nodes worldwide that will do all the caching for you. And the result of using something like CloudFront here is that you can get away with a much smaller backend. You can scale down the backend because now most of the work is done by those proxy caches all over the world. And the pricing is pretty simple because using CloudFront tends to be the same cost or less than the data transfer cost that you have to pay for anyway. So it pays for itself. This is how much caching can save you. In this case, our customer Team Internet in Munich, they added caching on top of one of their most popular DynamoDB tables, and boom, they saved 3,000 reads per second on that particular table. And then they thought, great, let's do it for all tables, and at the end of refactoring all of the tables to use caching, they were saving 20,000 reads per second, which translates into a lot of money monthly. And now Markus from Team Internet, he can pay for all of his team to go to reInvent if he wanted to. So let's go back to that cost optimization flywheel. We discussed a couple of architecture bits thing. Now we want to build, right? So when building something on AWS and you want to save money and be efficient here, the golden rule here is to avoid unnecessary heavy lifting. By that I mean, if you find a service on AWS, and now we have over 175 services, and that number keeps going up, if you find a service that is already doing what you want, there's no need to re-implement that anymore. So, for instance, instead of running your own database and managing and patching and all that stuff on AWS, just use one of our 15 different automatically managed database services. And now we added Cassandra to the mix. So if you were previously in the business of running Cassandra on your own on EC2, now you have a lot more free time that you can spend with other stuff. If you're running application integration services like message queues or stuff like that, workflow systems, go use one of the AWS services because they make it so much easier and you save a lot of time and effort instead of building your own application integration service. And it also lowers your risk because there's less potential for introducing bugs into the system, running into other issues. And again, if you're using some kind of analytics, go check out the analytics portfolio. Lots of services there that you can use, including Elasticache and Elastic MapReduce and all that stuff. And well, you get the picture. Don't reinvent the wheel. Here's an example from that same company, from Team Internet. They used to run batch jobs on Amazon EMR to do some analysis. And then they tried out, OK, what if we can do this with Amazon Athena, which is a query service that uses Hadoop in the background. And they found that their cost went down by more than 50% just by replacing EMR clusters, which are already pretty nicely automated, with Amazon Athena, which is a higher level service here. And the reason was that they spent a lot of money waiting for those clusters to be starting, and then they could only do their batch jobs. And with Athena, they were able to get rid of that waiting phase. And in exchange, they also got a simpler architecture that was easier to manage. So lots of wins down the road here. OK, let's spend the final couple of minutes here with saving on AI and machine learning. So who in this room is using machine learning in one way or other? OK, so there are a couple people here. So we gave this talk on Monday, and somebody left a comment here, and please do leave comments. We really live by your feedback. Somebody left a comment on Monday saying that, yeah, Konstantin asked, and then only 5 people raised their hands, and then he spent like all this time talking about machine learning, and everybody else could have gone home or something like that. Please don't go home, right? Even if you're not using machine learning now, think about using machine learning in the future, because machine learning really it's like having a weather forecast for your business. Think of machine learning as a weather forecast for your business. So think about all of your business processes and how you can use machine learning to be smarter about your business. Something like, when are these machines going to break so I can make sure I have the right replacement parts nearby? How many people are going to go to my store in the next week buying this particular item? How many items do I need to order to fulfill demand? All that stuff. And if you can't find any ways to use machine learning in your business, use machine learning to automate auto-scaling and predict how many machines you're going to use for a specific application. And there are some real savings there. Customer of mine, they used auto-scaling, and they were able to save 50% of their EC2 bill just by using auto-scaling. Then they applied machine learning on top to predict how much EC2 capacity they need in the future, and then they were saving 70% of their EC2 costs because they now had a smarter way of auto-scaling thanks to machine learning. And even if you don't use machine learning whatsoever, let's cut a deal here, right? So you're going to follow through this and try to think about these machine learning best practices in terms of your own existing things like batch machines, because machine learning is really high-performance computing for training neural nets, and you can apply these principles on your own stuff here. And even if you don't use any of these, at the end of this part, I'm going to tell you how to find the perfect Christmas present for your loved one without machine learning. Okay? Let's do that, right? So first, in AI ML, the same rules apply as ever, right? So the turn off unused instances rule can be applied to those Amazon SageMaker notebooks that data scientists use to build something. And simply don't run those notebooks all the time or over the weekend. Be smart and shut them down, stop them over the weekend. Second thing is automating everything also applies to machine learning, and we have a whole suite of services around Amazon SageMaker that will make it easier for you to run machine learning in the cloud, and that thereby you don't have to work so much and just can concentrate on your machine learning implementation here. The using auto-scaling rule here is already built into Amazon SageMaker. That's the great thing about SageMaker. It will take care of everything, including auto-scaling. And SageMaker understands how to use spot instances. So the use spot instances rule can be easily used with Amazon SageMaker here. So it all comes down to the unnecessary heavy lifting rule here, which really is the reason we built SageMaker in the first place. So this looks like a SageMaker commercial, and maybe it is, but the key thing here is the team has built Amazon SageMaker to make your lives easier, free up your time that you can now spend on building that next big machine learning thing. And then Amazon SageMaker does everything for you and makes sure to make everything very, very efficient along all of the steps of machine learning, which includes building your machine learning app, training your machine learning models, and deploying them into production. So when we go through the building phase here, using those AWS managed services, again, is a great way to start. Something like Athena, AWS Glue, AWS Lake Formation, because machine learning needs a lot of data to work on, and that data needs to be gathered and pre-processed and managed, right? So the other thing is, with machine learning, you work with labels. Labels are the answers that you're looking for and that you're giving the machine learning model to learn about. Like, this is a cat, this picture has a cat, this picture has a dog. You have to label those pictures. You have to attach cat and dog into those pictures, and that is something that can cost a lot of money. So Amazon SageMaker Ground Truth comes with a feature called active learning, where it will look over your manual process, over the shoulder of your manual labelers, and figure out how to do the labeling on its own, and that will save you up to 70% in labeling costs. So when you're building your machine learning application, you can experiment on your laptop, which is nice and easy, but as soon as you move closer to production, please use Amazon SageMaker notebooks, which have now become very, very easy, and now with SageMaker Studio, you get a full IDE for developing stuff. So please do take advantage of these developer tools. They make your life easier, they save you time, and time is more valuable than money. And when you use those SageMaker, you can automate the starting and stopping of those notebooks through a Lambda function. You can set up a simple Lambda function that stops your notebooks over the weekend, and that will save you a bit more money. And talking about notebooks, notebooks come in different sizes. You should always try to get away with the smallest size because the pricing is based on the sizing. And now we announced yesterday that the Amazon SageMaker notebooks are elastic, so you can adjust them on the go. Start with the smallest instance type for notebooks and only scale up when you really need them, and then scale back down. That will help you save more money. And again, you can run some small training things on your notebook, that's okay, but as soon as you move into something more significant, go use the training features for SageMaker because they make your life so much easier. Now let's move on to the training. How can you save money during the training phase? Well, again, don't use those notebooks. And the golden rule about autoscaling, and it also applies to any other autoscaling setup, is start with the smallest instance you can get away with. Try to scale horizontally by adding more and more instances of that type, because it allows you to scale very finely granular, and only move to a bigger instance once you have to. If you're running out of memory for one particular bit of your training stuff, then it's okay to move to the next one. Otherwise, try to get away with horizontal scaling as much as possible. And when you're using spot training, the thing to remember is spot instances mean they can be shut down with a 2-minute notice, right? So in the context of machine learning, you can implement checkpointing into your code. By the way, if you're not using machine learning and you're using batch computing for HPC, like computational fluid dynamics, like those Formula One people there, you can implement the same thing with AWS batch, where you implement checkpointing logic there, and then you can use AWS batch with spot instances here. The other thing is we provide you with pre-compiled and pre-optimized versions of your favorite machine learning frameworks, such as TensorFlow, MXNet, PyTorch. Do use those AWS-provided versions because they have been optimized for the specific platform they're running on, and that will save you a lot of money because running non-optimal code is going to cost you. And those frameworks come with specialized I/O libraries, such as TF-Record for TensorFlow or Record.io for MXNet, that will help you push data faster through your training cycle. And this is another thing that is also in parallel to other HPC applications. The bulk of the time spent during training is spent actually with I/O, trying to put all those data points through the learning algorithm. And by using a specialized framework such as TF-Record or Record.io, you can be a lot more efficient in pushing the data through. And there's another thing called pipe mode. Go check out pipe mode and try to figure out how to use that. Pipe mode essentially streams data through the training process. No need to load and copy and other complicated bits here. And then SageMaker comes with automatic model tuning features. And a tuned model runs so much more efficient in production, and that's how you're going to save money in production. So looking at the production bit of machine learning here, actually the biggest cost driver of machine learning is in inference. So about 90% of the cost in machine learning is spent on the inference phase because people train once and then they deploy to mobile applications or web applications that are used by millions of users. So this is how a lot of money goes into inference. So how can you save money there? Well, SageMaker comes with a feature called Neo, which will do code optimization of your model by getting rid of all the unnecessary bits and aligning stuff optimally to the hardware of your choice so that you have optimized executables that need less CPU and GPU resources. The other thing is there are two ways to use machine learning in production. One of them is a 24/7 real-time endpoint that you can query, but that is also running 24/7 and spending money 24/7. Or you can batch up requests and send them in batches. And when you send them in batches, SageMaker will start up a cluster, run the batch, shut down the cluster. You only pay for what you use. So if you can get away with a batch model, that's a lot more efficient than using those 24/7 endpoints. If you do use the 24/7 endpoints, think about deleting unnecessary endpoints, such as deleting those training and testing and other endpoints you might not need. And you can set up those endpoints so that you can use one endpoint for a full sequence of multiple models or one endpoint for different models running in parallel, thereby saving you on those endpoint costs here. And again, right sizing is always a good thing. Try to do some benchmarking and figuring out what is the smallest instance you can get away with. And you can use Amazon Elastic Inference to only use a slice of a GPU instead of a full GPU, because in inference, we don't need that much GPU capacity, or the new AWS Inferentia chip, which is in the new EC2 Inf1 instance type here. And again, autoscaling is always a great thing here. Now, that was the machine learning bit. I think you can apply those principles to any other application. So this is how you can put these in practice. And I promise you how to find the best Christmas present for your loved one. So here's the algorithm. Step 1, tell your loved one that you already got the perfect present for him or for her. Tell him or her you're done, and you're so much looking forward to his or her face at Christmas. Step 2, let him or her guess. Step 3, take notes. Okay, now you're lucky. In my case, my wife told me about this. I can't use it anymore. Okay, putting it all together. First, use EC2 spot instances, 90% savings here. Use reserved instances if you're conservative, or use savings plans. Very easy to use, very, very flexible, up to 72% savings. And that's something you can hand off to your finance department and let them figure out. Everybody should have a Jason in their company thinking about these things and how to leverage that. Then turn off unused instances. Think about these things. If you don't want to think about turning off all the time, go automate everything. Automate 100% of what you do on AWS. It will pay off hugely. If you're using serverless, try to understand where your code is spending time and why, and then try to get rid of those synchronous patterns where stuff is waiting for responses all the time, and be smarter by using things like multi-threading or event-driven code. And try to cache everything everywhere. There is always an opportunity to add another cache, and caches pay for themselves. Leverage managed services as much as possible. We have thousands of people in teams implementing those things on AWS as optimal as possible, because they get built too, right? So they know how to optimize database. They know how to optimize message queues. They can do it for you. You simply have to use those services when they're ready, and then you just use them. And finally, if you're using machine learning, if you're not using machine learning, start using machine learning now as a weather forecasting tool for your business, or as a forecasting tool for autoscaling. And if you are using machine learning now, please do check out SageMaker. Yes, this is a SageMaker commercial, but it will save you so much time on top of saving money. So let's go back to the cost optimization flywheel. And customers ask us, so what do I do with the saved money? I mean, Jason, he can now easily bring the whole company to reinvent multiple times here. So there's going to be some money left. What do you do with that money? Well, saving money really is the beginning of another cycle here, because you can now take that money and invest that money into new people. You can invest them into new developers that can help you build new stuff, that can help you be more innovative. And as you are more innovative, you are going to save even more money. So if you're missing those developers that can help you understand machine learning, then save some money here using those techniques, hire those developers, hire some data scientists, let them figure out better ways to save money, better ways to be innovative and to run your businesses. And if you want to learn more about architecting best practices, please check out the Well-Architected program. It's a website. Just say AWS Well-Architected, and we'll automatically bring you to that website. And it comes with the full white paper on cost optimization that Jason's teams have been using to create better architecture and to avoid costs that went into those 150 million saved costs here. And if you don't want to read, I can understand. I prefer reading novels or stuff. So there's much more. There are YouTube videos of our previous talks here. So you can check out the talks all the way back to 2014 and learn about other great ways to save money. You can learn about negative caching. You can learn about DynamoDB query optimization patterns. You can learn all this great stuff by watching the previous videos on reInvent. Every video is different. Every video adds another angle on saving money on AWS. So there are some related breakouts here. Unfortunately, the first one has already happened, but you can check out the Thursday breakout here, which is about optimizing AWS cost and utilization with AWS management tools. And with that, thank you very much for coming here. Please do check out our sponsors from training and certification, and enjoy the rest of the show. Thank you.